Hey folks, welcome to CSE 1322. This is going to be lecture number 10. Is it lecture number 10? It is lecture number 10. This is for the week of September 14th through the 20th, which is the same week as the test. I'm posting this one a little bit early because some of you might want to look ahead and see what's going on, but this material is actually for next week if you're looking at this week. I know that's very helpful in a recording. So today we're going to talk about interfaces. And the first thing to know about interfaces is that you already know most of the stuff about interfaces. That's the good news. They're very, very similar to abstract classes, which we covered in lecture number 8, just before the review. So we're going to start off with the problem statement as to why interfaces even exist. So I'm going to take this example here, and I'm going to say that I have an object called man and an object called wolf. And each of these class definitions for those respective things have, man has a weight and wolf has a number of puppies. Those are two private variables. And both of them have implemented a method called run. Cool. So now I need a werewolf, which is half man, half wolf. And so my gut instinct is to say werewolf inherits from man and wolf. But there's no way to do that. So the first thing that I need you to be aware of is that we've said this before, but it is impossible to inherit from two different classes in either C# or Java. Neither language supports inheriting from two separate classes. C++ does, but we're not talking about that. All right, so a part of the problem here, if we take a look at a diagram of how that would look, so man and wolf may indeed have come from mammal, but you can see there's a lot of ambiguity about what run would be called if I were somehow able to do this, which again, I am not. So this is not a real example. This is to show you that you cannot do this in either C# or in Java. And why you can't do that is because which run would you execute in werewolf if I said run and you hadn't overridden it? And even if you had overridden it, which one would you actually be overwriting? The answer is, who knows? I don't know, because this is impossible. So, first thing to commit to memory is there is no way to inherit from two different classes in either C# or Java. Cool. So now that we've got that out of the way, the question is, well then, how would I be able to do this if I needed to do this? Very specifically, if I had two distinct things that I needed to be able to write a class definition for, and then I needed to be able to inherit from both of them because I want some of the stuff out of one and some of the stuff out of the other, then how would I do that? And the answer is interfaces, and that's what we're going to talk about today. So instead of each of those classes, the man and the wolf, being declared as classes, they're simply going to be declared as interfaces. And now your werewolf can sort of inherit, that's not the right word, but it can implement both man and wolf and become werewolf. All right, so we're going to take this and we're going to look at a couple of things. But first, we have to talk about what an interface is. So the good news is, if you watched the last lecture and you learned all about abstract classes, then you have pretty much already learned most of the things you need to know about interfaces. Interfaces are a very specific type of abstract class. The specific is that there's a few rules that you have to adhere to if you're dealing with an interface that were not there when you were dealing with an abstract class. The cool thing is that you can implement, which is a magical word we're going to talk about in a moment, two or multiple interfaces in a single class, which is the kind of inheritance thing that we were talking about. It's not really inheritance, it's implementing. All right, so let's go through the rules. There are a number of them. So the first thing is that interfaces can only contain abstract methods. So when you're declaring an interface, you cannot write any actual code for how anything is going to work. You are merely giving the headers of all of the methods that you are going to later implement when you actually implement this interface. This is exactly the same as an abstract class. In an abstract class, you simply gave the header of the method and then you stopped. And then later, when you actually made that more concrete, when you inherited from the abstract class, you overrode and implemented all of those methods. All right. Even if you don't list the word abstract or virtual, all of the methods in an interface are inherently abstract or virtual. They are all abstract methods, so let that be clear. You must override the inherited abstract methods. All right. So when you say that you are a interface and somebody later tries to implement your interface, they must override all of the methods that you declared in the interface. That's the rule. There is a couple of little caveats to that and weird fringy conditions, but in general, if you attempt to only implement some of them, you are going to get a compile time error. Once you say, I am going to implement that interface, you actually have to implement the interface. That includes all getters and setters that are declared in the interface, if any exist. The next rule is that it doesn't contain a constructor. When you're defining an interface, there is no constructor because an interface, much like an abstract class, can never actually be instantiated. You can never make an object of type that is declared in an interface. So, to review, interfaces and abstract classes can never be instantiated. They're both the same in that regard. Every method inside both an interface and an abstract class are inherently abstract. Sort of. Okay, so we remember that when we wrote an abstract class, which was what we talked about last time, you can actually define some methods as non-abstract and other methods as abstract inside an abstract class. The class became abstract once there was at least one method in there that was abstract. All right, I'm going to pause for just a second to take care of something over here. All right, apologies for that. My phone was ringing, so I needed to deal with that. All right, so to review, when you are writing an abstract class, you absolutely can have methods that are abstract and methods where you implement some of the code in the abstract class. In an interface, everything must be abstract. All of the methods have to be abstract, so there can be absolutely no code written inside an interface. You are just giving the outline of each of the methods in there. All right, so moving on. There are a couple more rules. Any attributes that you define by default are going to be public static and either final or constant. So what that means is if you define an attribute in an interface, then by default it is public static and final or constant. You can absolutely you can change that in the implementation as to what you want from the interface within certain parameters. All right. The next thing to say is that the name of the interface by convention should start with a capital I. To be clear, this is not a rule that the compiler will enforce. You can call your interface whatever you want. But just to make it clearer to people who are looking at it, putting a capital I at the front of the name makes it easier to see that that's going to be an interface. There's also a keyword in there, so there's another good clue. But by convention, capital I is the first letter. And then the next statement is that you can implement, which again is a magic word we're going to get to in a second, multiple interfaces using a comma. So what I mean by that is, in our werewolf example, you could create a werewolf, and you can say it implements man and wolf. And the syntax for that would be man, comma, wolf. The exact detail of the word implement varies from language to language, so you'll see that in an example in just a second. All right, and then the final comment here is, just like with abstract classes, you cannot instantiate them. You can never make an object of an interface. All right, so let's take a look at some code. So first we're going to do Java, then we're going to do C# of the same code. So the first word here that's new that you've probably never noticed before is the word interface. So this is an interface called Talkable, which probably should be iTalkable because we said that we should always name it with an I, but okay, fine. So interface Talkable, and then we have one method which is going to be called talk, which is a void, and you notice that there is no actual definition for that method in the interface. It is simply void talk, open close parentheses, semicolon. There's no curly brace. The moment you put a curly brace after it, the compiler is going to yell at you and say you cannot implement this method inside of an interface. All right, so now how do we go about actually using that interface? Well, our next block of code says class dog implements talkable. All right, so implements is a new keyword here in Java. There's a different word for C#, so if you're in C#, you'll see that in just a second. But in Java, it is the word implements. And as we said before, there could be more than one interface that you decide to implement. So this could say class dog implements talkable, comma, walkable, comma, mammal, comma, whatever other interfaces you may have. There can be more than one. All right. Now, since this is an actual real concrete class, we actually do have to go in and implement stuff. So we're going to say override talk, and we're going to system.out.println wolf. Wolf, not wolf. All right, so public void talk is a method, and we are overriding the talk that we got from our interface up above. So that's pretty much it. At this point, if we say dog D gets new dog, which is just instantiating our dog class from up here, we can now say dog.talk, and as you would expect, you get a wolf. So let's talk about the C# implementation of this first, and then I'm going to have another couple of comments. So over here in C#, we actually named it iTalkable, so that's cool. And the word is interface, the same as it was in Java in the actual definition. Nothing changed up here. This looks exactly the same as the Java. The thing that's different is in Java, we said implements, which is different than inherits. Let me be clear, it's implements. Whereas over here in C#, we do the same thing as if we were implementing, we use a colon. So the syntax in C# uses a colon for the word implements and inherits. Whereas in Java, there are two separate words for that, implements and inherits. All right, so class dog colon iTalkable says we're making a class called dog, and it is implementing iTalkable. And then other than that, everything in here is the same, except obviously the way that you print is with console write line instead of system.out. And down below, it's exactly as I said before. And again, the syntax here, if you had more than one interface that you were implementing, would be class dog colon iTalkable, comma, iWalkable, comma, whatever the other interfaces are that you're implementing. And you may be implementing more than one. All right. So in Java, a class that implements an interface can override the methods, or it can declare the class as abstract. All right, now what does that mean? So there's a rabbit hole we can go down here. We can have a bunch of interfaces that at a very high level explain what different things would need to be implemented. Then we can have an abstract class that implements the interface, that maybe writes some of the code and maybe defers other code to another abstract class that could implement that abstract class, and so on and so on and so on, or can inherit from that abstract class is the right word there, sorry. So you could have multiple layers of this, where at the very top you have these very high-level ideas that are in interfaces. And then underneath that, either you can directly implement that interface in a class that you can then instantiate, or you can have this intermediate layer of an abstract class that implements some of it and then punts to a later level where you would have a concrete class that implements more of it. So just be aware that there can be more than one layer of all of this. You can have classes that are partially implementing an interface. To be clear, everything in both languages, once you say you're implementing the interface, you do have to say something about every method that is required in the interface. So if the interface listed 3 methods, regardless of whether you're implementing all of them or not, you have to at least have an abstract method or a concrete method in the object that is implementing that interface. All right. So this is allowable in Java, but not in C#, and this is what I was talking about here. So we have an interface talkable, and this is all exactly the same as before, but instead of directly implementing it, what I'm going to do is I'm going to say abstract class dog implements talkable. So now I need to override or be abstract for at least talk. I have to have an implementation for talk, or I have to say abstract talk to punt down to the next person who inherits from my dog class. All right, you cannot implement this dog, so because it's an abstract class, just like that. All right, so in summary, interfaces allow us to use the multiple inheritance trick that we were talking about above to avoid the diamond of death problem. And again, they're not allowing multiple inheritance, they're just giving us a way to have details that are at the top be implemented by a later class. They are very similar to an abstract class. However, they can only contain abstract methods, unlike abstract classes, which can have a mixture of the two. And finally, a class implements an interface, is the way that we would say that, and that's the key word in Java. In C#, it's a colon. So I'm just going to show you a quick example of how this might exist in the real world, and I have two examples in REPL. One of them is for C# and one of them is for Java. So we're going to start off with the Java one, and I'm just going to walk you through that one real quick. So here I have defined an interface in a file called ivehicle.java, and in here I'm declaring a max speed of 1,000, and I'm declaring that the vehicle is going to have two methods. One is called brake and one is called accelerate. They're both voids. So this is my interface. Really all I'm saying is that a vehicle will know how to brake, it will know how to accelerate, and it has a maximum speed of 1,000 by some measure, whatever that might be. All right, so I cannot instantiate iVehicle. Let me be clear about that. That is not a possibility. The only way that I can use this is I can implement an iVehicle. So that brings me to my car.java. So public class car implements iVehicle. So I am now implementing that thing from before. In order for this to work, I must actually have a definition for brake and for accelerate. If I do not have one of these, so I'm going to comment this guy out, and I'm going to attempt to run it, you're going to notice that I'm going to get barked at by the compiler because it's going to say you didn't actually override accelerate. So it simply says car1, car is not abstract and does not override abstract method accelerate in iVehicle. So absolutely will not accept this because I said I was going to implement it and then I didn't implement it. Now if I had made this an abstract class and I had put this as an abstract method, then yes, it would have accepted that. Okay, but back to this. I'm going to actually stop that so it doesn't run so you don't see the output yet. It's important that you remain excited to see that. All right, so we have two methods. We have our brake method and our accelerate method. Neither of these do anything particularly exciting. One of them says it's stopping and then sets the speed to 0. The other one says it's speeding up and it increments the speed. Okay, there probably should be a slowdown and some other stuff as well, but this is the bare minimum just so you can see an implementation. So public class implements iVehicle, public speed, brake, and accelerate. All right, so now we're actually going to use this the same way we always would. So I'm going to say car BMW is a new car. That's going to call the constructor, which I didn't declare a constructor in here, which is probably a problem. So let me go ahead and do that. I'm going to say public car, and I'm simply going to set speed equals to 0 in my constructor. And then after that, it does a loop where 100 times it's going to speed up, and then it's going to brake. And along the way, I'm going to see the speed each time. So as you can see, that's what happened. It said speeding up current speed is 1, speeding up current speed is 2. That's simply because of this for loop where I'm running through the loop and I'm simply calling bmw.accelerate and printing out the speed because it's a public variable. And then I'm calling brake. And at the time that I call brake, it says stopping, and you can see my current speed drops back down to 0. All right, so that's the example in Java. I'm going to flip over and do the exact same example in C#. This time I'm just doing it all in one file because C# allows you to do that. You can see on the right there that that all works the same way. So we have interface iVehicle. In this case, I have a variable called speed, and I'm declaring that there will be a getter and a setter for speed. So that's a little different syntax, but it is the same thing. I cannot just say speed without specifying that there will be a getter and a setter for it, because you're not allowed to just say there will be a variable without specifying how people are going to use it. So this mandates that they have to implement a getter and a setter. All right, and then I have my void brake and my void accelerate, and both of those are abstract because I'm not giving you any definitions. They both end in a semicolon, just the same as they did. So actually, all of this is pretty much exactly the same, except for the little bit of weirdness that I have to specify that my variable has setters and getters. All right, so down below, I'm next going to implement my iVehicle in a class called car. So I say public class car, and then remember that the syntax in C# for implementing is a colon, so I'm implementing iVehicle. I'm setting my constant speed to 1,000 in here, and then I'm simply doing all the things that I would do. I'm getting the default getters and setters for speeds because I don't care, they're fine. And then I have my public brake and my public accelerate, which simply print out and set the speed appropriately. And I have my constructor, which I apparently remembered to put into C# but didn't remember to put into the other one. And my main class does pretty much the same thing. I'm making two cars here, a BMW and also a Toyota. I'm calling accelerate only once on the Toyota. I'm doing a loop. All of this probably should make sense. There's nothing new going on in here. This is all code that you've seen before. Really, the new part is the fact that I have a class that is implementing iVehicle, which is an interface up at the top. The reason that I have this extra do stuff in here is I wanted to show you that if I had made iVehicle an abstract class by simply, okay, so before I go down that path, let me run it and just make sure that you can see that it is running, and yes, there's my speeds and my Toyota is 1. All right, so I'm going to make a quick change here. I'm going to add in a third method called do stuff. And what I have decided is that I'm not going to implement do stuff down here. I'm simply going to make it abstract. What is happening here? All right, somehow it magically moved space on me. So now I have an abstract public class car, and I'm implementing some bits of it, but I'm not implementing this last bit. Now, pretty much everything that's happening in main is no longer allowed to happen because I don't actually have a class anymore. I only defined an abstract class. But I just wanted to point out that that will still compile. So what happened here is I declared what a car would be like, and I gave you some of the implementation of it, but I punted on whatever do stuff is supposed to do. And so somebody else would have to come along and inherit from car, and then they would have to implement do stuff because they're inheriting from an abstract class. And so that's just to point out that this can go more than one level down. So I hope this makes it clear as to how abstract classes work and how interfaces work. They are very related, but again, the primary difference is in an interface, you cannot implement anything. You must just specify these are the definitions that somebody else will have to implement. All right, so that is the lecture for this week. And again, this is the week of the test, so hopefully by now you have taken your test and you did great on it. And the next set of videos will be us starting, or it's actually, there's one more set of videos related to Module 3, which will be coming out the following week, which I think is the week of, I always have to look this up, I'm sorry, the week of September 21st to the 27th. There'll be a final set of slides about object-oriented. So this completes the lecture for today. Lecture number 9, which is the one in between 8 and 10, I don't mean to sound funny, is a review for the test. So if you skipped forward to 10 to look at this one and you haven't looked at 9, I would recommend that you go back and look at it if it's already posted. So you guys have a lovely week, and I will talk to you all soon. Take care.